So hello dear students, welcome to channel Time to Cram, and this is the 10th video lecture of chapter 12 electricity class 10. So hope you already come to know that what we are going to learn in this chapter from thumbnail and title. So let's start the video. So these are the topic which I had already covered in my previous video lecture. So if you want to watch these videos, then click the I button. So before beginning today's video, as you know that we are going to discuss examples in this video lecture. So before that, let's recapitulate the formulas which I had already discussed in my previous video lectures. So first one is Ohm's law, that is V is equal to IR, which also implies that I is equal to V by R. We can make subject any variable from here as per our question requirement. Another formula which I taught you in my previous video lecture, that is R is equal to rho L by A, where R is resistance, rho is resistivity, L is length, and A is area of a wire, and rho is resistivity. So we are mainly going to use these two formulas for the numericals which we are going to solve in today's video lecture. Before it, let us discuss the unit of each of the variable here. As from V is equal to IR, the unit of V is volt, unit of I is ampere, and unit of R means resistance is omega. Here also R, unit of R is omega, unit of resistivity is ohm meter, unit of length will be meter or millimeter as per given in the question, and unit of area will be meter square or millimeter square as per question. So now let's first discuss the question number 1, that is how much current will be an electric bulb draw from a 220 volt source. So let's first write the given data, that is V is equal to 220 volt, which is coming from our source. If the resistance of the bulb filament is 1200 omega, so what we are given? We are given with resistance R is equal to 1200 ohms. So what we are asked to find? We are asked to find current which electric heater coil will draw from a 220 volt source. So to answer question A, we have to use Ohm's law, that is V is equal to IR. Here we are given with the value of V and R, so we will make I as a subject from here. So we will get equation I is equal to V by R. Now just we have to simply substitute the values here, that is value of V is 220 volt and resistance is given as 1200 ohms. So the value of I which we will get will be I is equal to 0.18 ampere after solving. Now let us discuss answer of B. So given data for B is, here source is same, that is V is equal to 220 volt, but here the resistance in the coil will be 100 ohms, so R is equal to 100 ohms, and again we have to find the current drawn by the coil of the heater. So again we have to use V is equal to IR formula. Here again we will make I as a subject, so we will get I is equal to V by R. We have to substitute the value of V and R. So here we will get value of I is equal to 2.2 ampere. In both the scenario, source voltage is same, that is 220 volts, but as changing the resistance, the current drawn is different for different scenarios. So you can note the difference here. Now let us discuss example 12.4, that is the potential difference between the terminals of an electric heater is 60 volts. So given data V is equal to 60 volt. Current is also given, that is 4 ampere from the source. So the now question is, what current will the heater draw if the potential difference is increased by 120 volts? So now here the question want to ask us that if the potential difference is 60 volt, then electric heater will draw 4 ampere current from the source. But now we have to find that if the potential difference will be increased to 120 volt, then how many ampere current will be drawn by the electric heater? Again here we are given with two values, that is V and I. So first we will find resistance, which will be common because we are just changing the potential difference. So resistance will be common in both the case. So first we will find the resistance with the help of Ohm's law, V is equal to IR. here we need R, so we will make R as a subject. So R is equal to V by I. So we will substitute the value of V and I, that is 60 divided by 4. So we will get value of R is equal to 15 ohms. This was the first case. In second case, voltage is increased by 120 volts and we have to find current, but we got the value of R here, that is 15 ohms. So we will use this value of R and V to find value of I. So again we will use Ohm's law, that is V is equal to IR. Here we will make I as a subject, so V by R. So we will get 120 divided by 15. So the value of I which we will get will be 8 ampere. So the current through the heater becomes 8 ampere. Now let's discuss example 12.5. Question is, resistance of a metal wire of length 1 meter is 26 ohms at 20 degrees centigrade. So here we have a metal wire, but we don't know the material of this metal wire. So let's start writing given data. We don't know the material, but the length of material is given as 1 meter and resistance of the material is given as 26 ohms. Now if the diameter of wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature, diameter D, which is 0.3 mm, but our length is in meter, so we have to convert this diameter from mm to meter. So we can write like this, that 0.3 into 10 raised to minus 3 meter. Also we can write, so therefore we can write diameter D is equal to 3 into 10 raised to minus 4 meter. Is it clear, students? Comment me in the comment box. Now what we have to find? Resistivity, which is rho. We have to find this rho. Now here no need of using Ohm's law. Here we have to use this equation, R is equal to rho L by A. Value of R we have, value of length we have, and value of A, which we will find with the help of diameter. So the left which we have to find is resistivity. So here we will make electrical resistivity rho as a subject. So equation which we will get is Ra divided by L. Rho is equal to Ra divided by L. If we talk about wire, so wire is cylindrical. We have to find the area. So what will be the area of that cylindrical wire? It will be pi r square. But here we have the value of diameter. So it will be pi d square by 4. We have to substitute all these value of pi and d from here. Area which we will get will be 7.065 into 10 raised to minus 8 meter square. Now we have to substitute all these value in this equation. So after solving this, the value of resistivity which we will get will be 1.84 into 10 raised to minus 6 ohm meter. So hence we got our required value. Now let's move to example 12.6. So a 4 ohms resistance wire is doubled on it. Calculate the new resistance of the wire. Like this also, a wire of a given material have length L and cross section area A has a resistance of 4 ohms. So what would be the resistance of the another wire of the same material having length half and area of cross section double? Again let's discuss what the question want to ask here, that we have a wire and now it is doubled on it. If we will double means we will compress the wire, then its length will be reduced. But let R1 for the new wire, which is for it length L will become L by 2 and area A will become 2A. Now what will be the R2 for it? So R2 will be, rho will be same, resistivity will be same for both, it is not going to change. So let's say L1 will be L by 2, A2 will be 2A. So R2 will be L2 by A2, which we can also write as L by 2 divided by 2A. So we can also write this as rho L by 4A. Now what we have to find here? We have to find resistance of this second wire, which is R2, and we have the value of this R1, that is 4 ohms. So To simply find it, we will take ratio of R2 by R1, which will be rho L by A divided by rho L by 4A. So here rho L by A is common on numerator and denominator except is 4. So the thing which is left as R2 by R1 is equal to R2 by R1 is equal to 1 by 4, and if we take R1 from LHS to LHS, it will be R1 by 4, and we have the value of R1 that is 4. So 4 by 4, so R2 will be 1 ohms. If length will be halved and cross section area of material will be doubled, then the resistance for it will be 1 ohm. Hope it is clear to everyone, and if not, then comment me in the comment box. Topic which will be covered in next video lecture will be 12.6, that is resistance of a system of resistor, will be covered in next video lecture. Thank you. Notes are uploaded on the bloggers page of Time to Cram. So visit the bloggers page to download the notes, and the link of the bloggers is given in the description box. So check the description box, get the link and download the notes. And if you find this video helpful and informative, then like it and do share it with your friends and classmates. And yet you had not subscribed to our channel Time to Cram, then subscribe it. And don't forget to hit the bell icon so that you will get latest notification and update when new video is uploaded. That's all for today's video lecture. Thank you.